Whipping up a dessert used to take a fair bit of muscle power until they invented a mixer with a motor in the early part of the 20th century. The first ones were very industrial looking and not much like today's sleek models. But with this invention, the job of pastry making has become a piece of cake. Today's mixers can whisk you into a world of the culinary arts. To make one, a machine straightens wire between a row of wheels. Computer-programmed forming tools make a total of a dozen bends to produce arc shapes, which will be used to build a whip attachment for the mixer. To assemble a whip, a technician fits the wire arcs into an aluminum hub, starting with the largest one and graduating down to the smallest. Underneath, a punch mechanism dimples the hub to fasten each wire to it. Here, they drop some dough hooks and beaters into a vibrating bowl full of metal nuggets. The friction polishes these zinc mixer attachments and gets rid of the sharp edges. Next, they thread a band of aluminum into a machine that bends it to the contour of the mixer. It's a piece of trim that carries the brand name. A bowl feeder now funnels hollow iron weights toward a system that threads wire through each of them. Mechanical arms pinch and bend the wire, making little hooks on the ends. 2 of these weights will be used in each speed governor, a device that keeps the mixer's speed constant despite changes in the load. To assemble the speed governor, they arrange a brass hub, spring, and a washer in a holding device, and then press fit them together. They attach the 2 weights to the spring assembly using the protruding wires. The speed governor system is now complete. Here's how the governor weights fly out to regulate the mixer speed. And now it's time to prepare the motor shaft. They lower this spinning steel cylinder to a revolving cutter. Lubricant keeps the cutter cool as it carves spirals into the end of the shaft. The spiraling grooves will allow the shaft to drive the mixer's internal gears. They install the shaft with motor windings and bearings attached into the mixer body. Next, they rivet electrical contacts to plastic control boards. These contacts will convey electricity to drive the motor. They deliver an electrical charge to the contacts to make sure they're working. Then they attach screws, nuts, and springs to complete the control board assembly. The control board will work in concert with the governor weights to control the mixer speed. For these mixers to really shine, they'll need a good paint job. To prepare the mixer parts for painting, they polish them on an abrasive belt. Then it's into the paint booth. This is a highly charged process. The paint has a positive electrical charge and is attracted to the zinc mixer parts, which are negatively charged. Now all the parts are in the mix. Coming up next, we'll show you how they all come together. Behind many a successful cook is a well-oiled machine that's made for speed, and that's the electric mixer. It produces the best results when the blades turn rapidly. If they turn too slowly, they won't mix the batter thoroughly, and that means your pastry could be a flop. To assemble this tilt head mixer, they install a gear to drive the attachments. Next comes the stator, which creates the electrical field for the motor. A dab of oil, and then they mount the shaft and motor windings inside the unit. They slide 2 motor brushes into pre-drilled holes. The motor brush will supply electricity to the internal components. This bearing bracket holds the motor in place. They lubricate the front of it before installing the electrical control board. They wrap a trim band with the brand name on it around the outside. Next, they pour gobs of grease into the section of the mixer that will hold the gears. The gear section will be sealed, so the grease can't leak out. They attach the other half of the unit that has some gears already fixed to it. They insert a drive pin in the shaft that moves the whisk and other attachments, and screw the 2 halves together. They apply more grease to this section, and then install the planetary gear. This gear will rotate the mixer attachments around the bowl. With a mallet, the worker hammers a pin to attach the planetary gear. He taps a decorative ring onto the outside. He mounts the motor unit to the base and marks an identification number onto the bottom. Now they take the tilt head mixer for a spin. And the next step is to adjust the speed. The technician installs a speed setting tool in the hub of the mixer. While the gears turn, he checks the readout and tunes it up. Each mixer has to be able to make a dizzying 200 rotations per minute. They cap the hub. The final step is testing the beater. They check that it's correctly positioned above the bowl. One last polish and it's ready. Over at another station, they're making a more commercial type of mixer, one with a bowl that lifts to the beater instead of a tilt head that lowers to the bowl. They screw a base to a bowl support piece. Then they attach the lower housing for the beater motor. As the mixer moves on a conveyor, they install the motor and gears. They add a generous squirt of grease to lubricate the transmission, and then encase the top of the motor with more housing. Continuing down the line, they install the electrical speed controls, topping it off with more housing. They wrap the signature piece of trim around it. Using a probe, they check the wattage and speed. It passes inspection and it's ready for packing. It's taken approximately 10 minutes to assemble this bowl lift mixer, but it's been made to last a lifetime. And with such a range of attachments for these mixers, you can really go stir crazy.